Hello, this is Mukesh Kildial. Today I'm going to talk about Oracle Agile 932 and the problem and the challenges. Let's begin with a case study. This case study consists of two problems. One that is infrastructure and database related, and in the part two, we will talk about the database, Weblogic server, Agile as a whole, how the problem and their resolution techniques. So this is an agenda in which we will first talk about the architecture, then we'll go about uh, determining the problem one and how to identify a problem and what are the possible areas to look for, and then we look at the solution, and then we'll look at the part two problem, same procedure as how we go about identifying the problem, and then present a solution to part two. And there are at the last, I have included all the resources that I referenced or are helpful for you guys to look forward beyond this particular solution. And these techniques that I'm going to talk about can be implemented in any application, database, or infrastructure area. So let's start. First, we will discuss the architecture. Let's look at the architecture. So this is as simple as it can be, an HTTP server, and then the layer with LDAP file manager and database server. So the good thing about this LDAP server is that in case in the future, if you decide to implement single sign-on or Oracle Internet Directory, IDM, and those kind of stuff, you could use it because LDAP server you implement there and can implement single sign-on on Agile. File manager is another piece in Oracle Agile that is of great importance, because if you have a architecture that you design which is geographically dispersed, I mean to say that people are using Agile from all different places, and latency will increase as the distance increases if it is not in a well-tuned closed internet. What I mean to say is, if company has its own private internet, private cloud, and let's say MPLS, then that might resolve some latency. But still, what we could do is, if it is a dispersed environment, we could put a file manager near to the location where the access will be maximum to eliminate the transfer between database server, application server, back and forth, being one single server or one single server that is in the data center. Another, if it is not dispersed and you could live with one file manager, then that would be. So it's a little bit about the file manager. And this is traditionally how Oracle thinks that the well-tuned enterprise architecture should be. They're implementing some load balancer, and on the back end probably the database should be rack too. But this is how a typical enterprise level architecture would be. However, this present client, we don't have a load balancer. It's pretty simple, even though it is a dispersed environment, but I lost the battle of having multiple file servers. So it is running still on the file server that is on the server. That's a single file server, you can say, with multiple strand, but of course. So now we'll discuss how and why I start looking on these areas. So when I've been asked to come and determine why the problem with Agile is, and then the problem statement was the application server, very specifically, the application server reboots every now and then, and there is no clear-cut time when it reboots. It could be within 2 weeks, within a month, twice a month, sometime once a month, thrice a month. So what I did is, when I came, I started looking a holistic picture, a whole infrastructure that consists of network, traffic, client, how they're accessing client desktop, client laptop, server, which include application and database, of course, plus their operating system architecture and tuning and how the parameters are laid out. So this is what I'm indicating here with these flash or you can say first I look at the client, and then I look at the file manager as I indicated, how the application server as a whole, and then we go from the database server, look at it, and of course network and OS. So this is my approach to look at any problem that we incur, even though the indications are very clear that only application server is reporting and the focus should be on application server. However, when if it is a crunch time, if it is a production issue and you are on site for a long time, then that's where the focus should be. But as an outsider, when you're going to look at a holistic picture, you've been brought in to address the issue, then I think the way I looked at it would be beneficial. You can be just to the situation and deal with it as it comes, but this is one way of doing it. So this is what, as I indicated, the problem before server reboots. So what I did is initial check. I'll look at the JVM, I look at the all JB server command line, file manager, file server, HTTP, Tomcat. What they seems to be just fine. When that this is local, there is nothing out of ordinary, some additional parameter or less parameter that would cause the Weblogic to crash or any sort of those things. So it looks okay. So that move on. We'll look at file manager, how the pool sizes are, their log files, memory structure, is there any constraint on pools, since it is a dispersed environment, is there any timeouts happening? It's because of this the file keep on spinning off and maybe causing a memory leak or some kind of stuff. So just to look around. So this is what I'm indicating, where and how many places you go and look about these things, and then take a snapshot between before the server hangs and server do not hang. For that one, I kind of have to keep on looking around and wait for the server to hang. And it so happened that it did happen in within 2 or 3 weeks, so I was able to do the last piece of it and look at the network, how the network. So the current client was it still is in an MPLS environment, and MPLS has been defined as a cloud network, so to speak. AT&T provides this, and it has each location of office will be a conduit to a bigger cloud that will have a direct access to, as long as you want to go within the company defined architecture, no matter whether you are in Germany, Australia, Canada or US, they will just plug in, and then you will have a priority depend on the level of service you took, and then that's what the MPLS essentially is. It's a little picture I took from the internet. It's not, I didn't create one. And then look some latency test. This is an example and a picture taken about SolarWind, how it looks. My current client uses SolarWind to do all these network traffic and optimization, and look around the troubled areas or the stress pull areas and what people are doing, or somebody watching a Netflix movie or somebody doing something that will show up in this one, and we'll with username and all that, and ask them, hey, why you using bandwidth? Because at certain places, even though this is a dispersed environment, a big company, a big pharma company, but life science company, I'm sorry, but still with MPLS they keep on acquiring new companies, right? As they acquire new companies, the sites that were there before the acquisition may not have a perfect network condition. In some cases, there are only 10 megabyte pipe and 20 megabyte pipe. So we have to take into the consideration all the facts that are present there and how they are accessing the environment. And if somebody in 10 megabytes they start watching movie, then you know how R12 or other application will behave. So this is what I go and I do a traditional ARP and ping to, and let's see how the latency is. It's not too bad, 133. It's okay for R12, but I think it is little tight for Agile, essentially because of the nature of file movement and the big file movement, or architecture drawing, or blueprints and all those kind of stuff. So I look at the database log, and essentially this is typically, you can see on the dumps alert log, and I ran some AWR report. I find high log file sync and long running sequels and this error. And contrary to traditional belief, high log file sync means if I go on traditional belief, high log file sync, we keep increasing the size of log file, put multiple log file. But to believe me, they had the biggest size of log file I have seen, the 4 GB log file size, and multiple the 6-8 groups. So if that would be the case, then I should not be seeing the log file sync anymore. All right. But that was not the case, and after further analysis, I was able to reduce the size to 1 gig and reduce the number of groups to 6, and eliminate completely log file sync, because the issue was not because of what traditional belief or blanket solution would be, but something else. And let's look at that one. So this is OS, and the first thing is in red, but if you look at this number, this comes to be 4 terabyte, and if I look at this node ID, nowhere in node ID say you should put 4 terabyte, but this is in all operating system, HC systems file kernel parameter. This has been noted there, and it's been written that, oh, Oracle says it, and nobody even can question it, but that's not right. And that was the discrepancy out there. You don't even have 4 terabyte of memory on the server, and why would you have a shared memory's maximum size to be 4 terabyte? And then one thing that I did is, when I was looking around Weblogic server and all those things, I couldn't find any indicative evidence that this may be the cause. I couldn't find anything. Now I say, okay, let's look at the kernel parameter. The parameter didn't look out of the ordinary except the one I'm mentioning here, but that would not if it is application server, an application server is causing, and this is all over the place, even on the database server, and it didn't make the database server to go down. Why would this make the application server to go down just because of shared memory max, because we're just using Java? So I went a little deeper and look at how the network status is, and to my surprise, if you look at this time wait, this looks very suspicious to me. What it essentially telling me that the connection from Agile are not getting closed. So let's look deeper into it, and then, even though I know probably that's where I should be digging further on the network connection area, but I said let me complete my research, or all the areas that I want to cover, and then put my things on table, and then look at each and everything. So this is because this is a thick Java client instead of thin that we generally use in our tool, but it uses a thick Java client. So as per the usage, our tuning should change and should accommodate how client is communicating with server. And this one, generally what happens is, if you look at the network setting, it generally says the use browser setting. Well, in many cases this may not make any difference, but think about if he's going to go and talk to a browser and ask for what your proxy setting is, and then decide how to connect, there are some time gap or time lag, even though it's very millisecond. I would generally choose a direct connection, but right now I'm just looking at it. So that's the potential area. Then another potential area would be, what is the size of the file? See, this is very important. If you have a slow disk and you have a huge file size, and it is a disaster, because then you're looking for spinning on IOs and writing the files. That may slow down because you're going to write a lot of temporary files over the period of time. But if you tone down the size of the file, then at one point of time it's going to override them, or you can delete the file easily and restore and restart the session. So this is another area. And then the thing that I would really look at, runtime parameter, because this is a thick client. I would look how much memory I have on my laptop, or client laptop, or user's laptop, and tune it accordingly, because this helps a setting on the client side memory for a thick client to communicate and cache in better. So I look at the memory for, this is my laptop. I had a 4 gig Windows 7 64-bit, but that's what I advocated, that anybody that is using Agile and need to have a thick client, minimum please give them 4 or 8 gig of RAM, because then I can tune Java better and accommodate all their requests for file movement and other necessary things. So this size and disk size, of course, as I indicated, means if you have a 54 RPM disk size and you have a huge one allocated, so you rather allocate it less and not tax the disk that much, and do it accordingly. So you look at the disk size and the speed of the disk was kind of discounted. So after looking all that, then this is what I came up with the first solution, that I looked at this one as I indicated before. So this means that the new ephemeral connection cannot be allocated after one point in time, because there has to be a limit to it, unless somebody tuned by default is around 60 to 65,000. Once you reach to that limit, not exactly 60, even though to 50 or 52, there is a potential that server will hang. And the reason being, even though these all connections are not getting closed, even though they take a very little memory, very little CPU, but nevertheless they do take some resources, and if this number becomes too big, the resources will eventually matter, even though they won't matter for 1,000 or 10,000. When it becomes 50,000, it will matter, because there's so many of them and they need to be closed, period. I mean, you need to have open the new connection, they has to be get closed, because somebody is checking whether it's a kernel, whether that is closed or not, keep on going back and forth. And this, so you have to really see that only the acknowledged on the 17 was not acknowledged and closed. And and I don't believe that these are the Agile one, because these are outliers. I mean, they could be direct connection that somebody is using, maybe SQL developer or something of that sort, and closing the connection directly. This tells me that it is all Agile related connection. And then I just wanted to check if they have increased it. If they have increased to 120 per se, so 30 or 50 or 60 would not make that much of difference, even though they will take some resources, but it will not crash the server that sooner. But it is 65, and in first week itself is 30. So obviously it makes sense that 2.5 or 3 week is a prime time for it to go down, if people are accessing it the speed they were doing in the first week. But if the people are not using it, well, you can sustain a little bit longer then, and that explains why it is sometime once a month and sometime multiple times a month. So this is still a default. So this is a picture that I took from the server framework, and explains it a little bit better, and you can go there and make a little bit readings on it to understand better. But this essentially what I'm talking about is the last acknowledged has to be acknowledged for each TCP connection to get closed. So that's the essential. This is the flow chart. You can go in further detail to really look into it, and this is a pretty good resource to read about it. But essentially it need to get closed, any connection, especially TCP/IP, so that we will have a new connection available for new client those are connecting. So this is another picture. What I'm trying to say, that the application closes sends fin. If it does not, then that's the problem. So what we did is I went ahead, and Oracle probably had this in mind, and in release notes, I think somebody missed the release note. They do make these suggestions, and I tuned them a little bit, so that okay, you're gonna probe so many time with so many time of delays, you're gonna clean them up. I mean, that's essentially what it is trying to tell. They put these parameters in place, and our problem was solved, because that is what it was happening. So my guesstimate turned out to be a correct diagnosis of the problem. But anyway, that was done. But since I was looking entire servers and architecture So I thought it's a good idea to get rid of the other problem that I'm facing. And since the server Oracle has done this tuning in a Solaris environment, the upper top one. So I just translate that into Linux, and I say, okay, let's do the best practices. So anyway, the only parameter that I could not translate is UMPSS, because that's specifically for Solaris. Other than that, as many as I can translate, because Oracle already done a lengthy performance tuning for Agile on a Solaris box. So I would directly translate that to other parameters those were missing from originally, uh, just to cover, because it's already been done. I don't want to reinvent the wheel, so I'll just to choose that one, right? And then I would put this one, because on your Linux, if you have worked with WebLogic server, the first when you have a Fusion middleware console, it takes forever to come back, and because it generates the random number, and in most often it has issues with that one. You can read more on that one, but this is what I put on the start Agile file, where they are referring all the Java parameters. I put them in there, and that slow console problem gets resolved. And then I made the another changes. I just see the traffic, how much file traffic is there, and basically I just bump them to have a common heap size minimum and maximum to be same, and being 128 I made a standard to, well, I have done it iteratively over the period of time and in the development to see which one is better. Generally in most cases 128 MB would be good, but I seen the improvement, and I ended up doing it to 512. It worked. So now I did some database changes, and I would explain to you each by. So share pool reserve percentage to remove that error that I shown before. Actually, by default, it is 5%. So when you have automatic memory management enabled, by that 5% it will allocate to the share pool. So looking deeply into that issue, I increased that one to 10%. And I have not seen that message again. Another one is log parallel is max, and then this is contrary to belief, but I have referred at Oracle note. So what it does that by having log parallelism, it will create multiple public strand, and then it will help creating multiple redo allocation latches. And when the multiple allocation latches with multiple strands will be created, it really uses all your files, and then that's how I reduce the from 4G to 1 GB when not to, because now 6 of them gonna write at one time in one file, and if we can see what will be the particular size for the log file from the log buffer, and then that is going to write one time and eliminate any issues. Once I did that one, I was completely, after making the changes to 1 gig, was able to overcome the log file issue. And the other thing is that what you need to see is that how much memory or how many CPUs you have on your system, because as per Oracle recommendation, 16 CPUs should have. Any increase after 2 would have a 16 CPU for any increase. So 16 times 4, 64, and all those kind of. So you need to do that calculation. You can read a little bit more about it, but this is what I think. So this is another parameter, the PGA one, and this is a very traditional thinking goes is that by default the PGA max size would be 5% up to the PGA aggregate target. I mean that's automatically should allocate as long as it is less, the PGA aggregate target is less than equal to 2 gig. However, if it is more than 2 gig, then it should be defined. It should be defined as dynamically, right? It should go dynamically defined. But as per all my 10G and 11G experiences, I did not see that working as documented. So what I have done is I always create experience a rule of thumb. If it is below 4 gig, I will keep 1 to 3 to ratio or as such. So I would always keep it minimum 1 gig. In this one I keep it 2 gig because we created a aggregate target of 8, so 1 to 8, 1 to 4 ratio, because this is for all session in the system, and this is for individual one, and that's how I come up. So this is another interesting parameter that I put it up here. Maybe will spur some debate, but this is AQTM processes. So actually the AQTM processes divides into two processes. Now, like two kind of messages that it will process. So one is persistent message, and then another one is a buffered message. So if the moment, if you say explicitly 10, then what Oracle is saying that, so there is no buffered messages available. All will be, whatever you are allocating here will be persistent messages. And then that's the definition. The buffered messages are only used when you are using replication. So I'm not using replication, I do not care. But then there is another document. If you do 10, it should be dynamically allocating between the persistence and buffered messages. So which one to take? And at that time 10 was maximum. And since I was not taking replication, I did not know which one to take. I put RTOG with 10 and my performance for the AQs and Qs improved very much. It was very good deal for me. But you need to evaluate if you are using Golden Gate or such kind of software where you are using replication. You need to have some kind of buffer message, and at that time you need to test it in the development environment. Really it does that, dynamically allocates, or you need to exclusively set. At that time you can think about 5, 5, 6. You set 6, then 4 will be buffered messages, or 4 then 6 will be buffered messages, and all that. However, on 11G the maximum size is 40, so it should not matter if you're using 11G. That's what I was using, 11G. And so that's a little background on that one. But and then I made some SQL changes for the connection timeouts, and this is what I put it in there, so that those timeout essentially go away. There was some latencies between, as you seen, the latencies between the client and the whole server, the entire server length of database and application, and I put these parameters in place there for that one. And then obviously this one we asked them to remove from all the servers and put other parameter in place. As this is application server, so I did not enable the huge pages. But what I end up doing is on Linux server, on database, I enable the huge pages, so to make the performance better. If you can see, I think you can read more on huge pages, but I added huge pages, so the essentially what I'm trying to do adding huge pages is, instead of kernel maintaining my memory pages in little tiles of default size, I'm asking them to make it a big page size, so that it only have to maintain 4 or 5 pages instead of hundreds or thousands of pages. So that's the gist of it. But then once you read through it, you will learn more about it. This is in sync with how Numa uses, how huge pages uses. These all are technologies that helps perform Oracle database or other databases for that matter. Whoever can utilize these technologies perform better. So these are the something that I did a house cleanup, maintenance kind of job, but the problem was solved from the TCP connection, and then we put it in there and thinking, it will help in go live, and it did. But what happened is then suddenly they started using the dashboard, this is how the dashboard looks like, and they have multiple queries you can do, and they use as a huge query the selecting virtually everything from the databases, and that's multiple time. When this type of query running, it crashed the WebLogic server, that eventually crashed everything. And there was a service request open with Oracle, and what Oracle said that the way dashboard is being used is not intended to be. So they essentially close the service request that you are not using it the way it was intended. and then it came to me, and I started looking. But this to give you a picture how the dashboard looks like and how the queries will, whenever you come up, these all four query will fire up and give you the display result. I did not know what Oracle meant by it was not being used the way it should be, but anyway, but that's not my area to comment. And then this is how the user develops the query before it goes to the dashboard, and you see that they can keep on doing plus 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 join statement, and then they create and then the application goes on background and writes a SQL select query based on how you do here. So anyway, then when I started looking at it, I went and I started looking from Java. So I start JState, high status of how the Java pages are doing. As you can see here, some samples, not all of them, but I couldn't find all of them. It will be a huge presentation. I didn't want to be a long, lengthy one. And then I downloaded the GC viewer and enabled the verbose on Weblogic to capture the how the garbage collection is happening and looking around it. So what was happening is GC peaks whenever a database query multiplies, and when it peaks up, it is still spinning because the database has not responded back, and that eventually hangs the JVM, and then Weblogic crashes. As simple as that's the gist of it. What I went to AWR at that time when the system was crashing, I went back and ran an AWR report just before crash, and I noted the timings because it happened multiple times. You can simulate this because you just need to run a couple of queries and it will crash. What I have noticed here is that they have so many ands and trust me, this query had easily 150 plus ands when the query they made it. To me, that is not a perfect use of a SQL query, and that is what it was most likely causing the issue. I cannot determine but this was a bad query, and when I ran the query by itself, it hung too. I ran with the different hints, first rows, all rows, rules, and all kinds of stuff. I did permutation combination, the same query copying and running. Finally, I found that, and in one instance, if I have a proper, if I go with the rule based, it was performing better. So that gives me something to work on. And then, as I said, I can't do a SQL code tuning because it's Agile code. We cannot fix the code. So what I ended up doing is I used the OracleAgile932 feature. I tuned that was the database side, and then before doing that, I wanted to eliminate that at least the Java, the WebLogic Java would not crash. Its JVM should stay up. So I tried to do many permutation combination. Here is the result, and that really worked for me. So what I did is I removed the minimum size because in Java 7.2 onwards and in Linux, there is a default size. I will come back to that one. There is a default minimum size and there is default maximum size determined by the size of the memory on the system. So if we understand Java 7 and the way it works, then we do not need to have a heap size of huge heap size, and that would work perfectly up to 2 gigabyte, maybe 4. I do not know, but up to 2 gig in R12, as we all are EBS people, it works. If we minimum and maximum heap size of 2 gigabyte, perfectly works. After that, it becomes too bigger of heap, and if the garbage collection kicks up, there are hangs and all these things starts happening. So if you look little deeper on GC viewer, JStat, and all those kind of things, you do little determination, you think that it is not a good idea to have it. So what is a good idea? You should have some minimum, but what minimum? How would you determine it? And then you will come to, when you do more research on it, that okay, by default minimum, let's take the default minimum because we're gonna grow beyond 8 gig or 16 gig on the WebLogics. So that's how I eliminated that one. And I end up using the threaded log buffer. So what instead of having a whole lock on entire buffer, I will give them a threads that they will have each session will have a lock on their own area, So enabling the threaded lab will eliminate the pauses, and whenever that will eliminate the entire locking and pausing. And then we will have this is a crazy survival ratio, as you can see, but what happens is when you put a survival ratio too big, what it's try to do is that it will not have any tenuring threshold for the new generation. So what essentially what I'm saying is I'm specifying a high survival ratio which goes along with this tenuring threshold, zero tenuring threshold, to ensure that there's very little space is reserved for absent survivor. That's what we're trying to do. If the survivor is absent, we don't want to reserve any space. So what we are doing, abnormally high survival ratio for that one. And then we're going to use, actually, if you look at the we have done a concurrent manage mark sweep incremental mode, and this is a region for that if you prefer a shortest garbage collection pauses, and there is a long-lived data that generates a larger tenure generation, right? So if you look at Agile, the session that when you pull the whole data, specifically in this case when we are at a dashboard, so there is a large tenure generation because you are pumping the huge data into that one, and because of that the pauses are happening. So we want to eliminate the pause between the garbage collection, so we use CMS incremental. And now you can read about why this is there, why this is there, why this is there, because the moment I'm telling you this background of CMS, you can see how these fraction will play around, and there is a referred material for that one you can look at. So this is what I was talking about, because if you look on Linux background, so the default initial size is 1 gig, the default maximum size is 16 gig. How that comes is that the calculation is about this. XMS is 1 by 64 of the RAM, and XMX is 1 by 4 of the RAM. So as long as you have a sufficient RAM, which you will be if you're running WebLogic in the 64-bit system, then essentially if you don't define both of them, it will pick them from there, and that's what it is. But do you really want a 16 gig? If you don't want a 16 gig, then you define it, and that's what I was talking about, why I took the approach that I took. So this prolonged the crash, but then at least I know that it's not JVMs are not hanging. So the Java is performing better. But then now, if database is not returning the query soon enough, so Java will still, it won't hang, but it won't return the query. I mean, what will happen is it will keep on running, a dashboard will keep on spinning, but dashboard will never finish populating the data. So then I went further. I say instead, before going to database, because I wanted to touch the database last, I did some tuning on the WebLogic server itself, and these are the few things that I did there. And what I would like to say that the statement cache size I increased 150, it was not set, and I changed this maximum loss file size buffer from numbers, it was a huge number, to a more logically approachable number. And why I'm saying logically, because 11G by default makes it a log unless it goes to beyond some 20,000 or something, then it will treat that as such. But then what happens is whenever you go beyond ordinary, beyond standard, no matter which code you look at it, if it has to go beyond the ordinary, not the default, it has to go through the else kind of condition. I mean, I'm just giving you a simulation that if then else condition. If it is going to go on ordinary, then that is what is going to satisfy first one, otherwise it's going to go. And in each kind of these things, there is some cycle of resources or some cycle of time is elapsed. So this is how 11G wants it, this is how I gave it to them. And then I put the maximum connection, those were around 60, and increase them. And I just put the Java fast cache path, and also I enable the concurrent queue for request manager. So this is kind of I can parallel this to with concurrent manager of R12. So it will not lock the resources, and that's how I enable this one. It was not enabled. So these parameters, you can read more on it. If you have a question, you can write to me. I will try to explain as much as I can, but I went through many iterations to come up with these one. I did enable this one, disable that one. The behavior will change from one end to another end, and like a swinging pendulum. finally these worked for me, and this is how I did and why I did. So now JVM working, sometime query finishing, sometimes. So that was a good sign. So now I know that I have taken care of the WebLogic portion of it completely, application tier and all those parameters, things has been taken care of. They are holding up, they can hold up to the big queries and all that. And then some query came back to SQL tuning. So now what I did is, actually this SQL tuning is, now I'm trying to tell the database, hey, there is some very bad queries and unpredictable bind variables, and I don't want you to use adapter cursor or cursor picking, all that want to be eliminated, and you anticipate those bind variable when this runs, because it learns by how the query runs, and the next time it will be faster because you're already caching them. So that's the whole the SQL tuning background in a very summarized fashion. So what I did is, as I said, I disabled adapter cursoring, because what adapter cursor does is it adapts as it needs. So it has to adapt anyway. Some query has to come first, then it has to learn about it, then adapt to it, and all kinds of. And then since cursor sharing, I want cursor sharing to be exact. I don't want it to be that those adapter cursor will take place and similar or all those kind of steps, because in similar it will try to force everything to bind variable. Sometimes I don't want it to force bind variable because of the nature of it. I may have my skewed columns, or may have some other reason I don't want to push the bind variables. I want to have literals in these cases. So sometime you need to look at these adaptive cursor. They are good tools, but at times even on R12 I think we disable them. But how we do it, we just put this one in there, but that doesn't do the complete job. It's 50-50. So we need to put these parameters in to really completely disable adapter cursor sharing. So this is what I did. These are the existing value before I did, and I changed them to this one. You can look at them at your time, pause it if you really want to note it down. And then I enable the SQL tuning with the default tuning advisor, and I change their timings also. So these are the how I did it, but this is I will summarize them. So what I essentially did is I want SQL tuner to be enabled to tune the SQL tuning, but I do not want it to go to indefinite. So there are some time limits I put in place, that okay, for you the local time is specified the maximum amount of time in total, because this is total. The total time you will spend on the tuning is this much, because if it goes beyond, don't tune it, because then you need to. I don't want it to be open-ended, and then for each session this is the time. You can play around and how and what will work. Maybe some other parameter will work, but I also did not arrive to this decision just by putting it. I keep on changing back and forth, calculating and some kind of, because sometimes you do need a little more time here, because if there are query is really bad, you do want to go with little bit, but you do not want to do it too much, and that's how I did it. And that did it. I mean, actually, essentially, when I did it, this is what it is. So sometime the dashboard will populate in 2 minutes, sometime in 5 minutes, sometime in 10 minutes, right? And the user will complain why it is not consistent, and that is what the SQL tuning thing is, that it may not be consistent, but it will come within 10 minutes before, which was never finishing, crashing, coming in hour, coming, not coming. So they should be happy about it, but I tried to explain. I don't know how much I was able to convince them, but this is what it is. And these are some of the resources I will try to leave with you, and you can essentially these one, there's a very, very good documentation. I pull it through. This one you can see the redo logbook that I was talking about, latch contention and that log parallelism max. There is a note about that one in there. And this should help you in going future troubleshooting and all that. And I will say thank you very much for your time listening me. It could be boring at times, but thank you, and we will do some other session sometime if I get time.